In this video, we will understand what is the effect of the PID on the system. So by using the MATLAB software, we will create one system, and to that system, we will connect the one PID block and then understand the effect of the PID on the system. In the MATLAB software, there is a simulating tool. If we click on the simulate library, we will find out the one dialog box. In that, we can find out the various functions, okay, various tools. So I want to create one system, one model. So here, enter into the new, then click on the control N, or you can directly place the control N. We can find out one window, or click here, then we can find out one window. Now in that window, first I want to create one transfer function. So transfer function block is available in that. So in library we can search that transfer function. So if I click on this, if I write the transfer function, we can find out this transfer function. So this is one transfer function. Okay, then I want to see the effect. So there are some sinks, means if I want to see the effect of the system, I can use the scope and source. So here source I want to provide, that is one step input. So here simple step input. Okay, now see the effect on the system. So first connect the step input to the transfer function. So transfer function connect to the scope. If I click on this, see, this is the output of the transfer function. But if I provide the step input, but here we can see only one graph. If I want to combine two graphs by using the scope, we require the mux. So we will check by using the mux. So again, enter into the library, search this mux. Okay, various type of the mux. So I want to use this mux. Here I can combine the two inputs. Means if I want to say delete this, go here, take this. Now connect this transfer function to the one side. Then another thing is I want to use your step input, and I want to see the step input and at the same time output of the transfer function on the scope. So first I connected the transfer function. Now I want to connect the step input. See, and connect this to the scope. Okay, now click on the run. See here, we can find out one step input and one transfer function. Okay, transfer function, output of the transfer function if we provide the input step input. Okay, now I want to change the transfer function. So here facility is provided, double click on this. If I change the transfer function, suppose two coefficient, here I will take the third coefficient. For the numerator 2 coefficient, denominator 3 coefficients. So click on OK. We can find out the change in the transfer function. This transfer function here, we find out the change. Then this is, it's become s plus 1, s square plus s plus 1. If I click, see the effect in the scope. See the if I change the transfer function, I can find out the another response. Here input is the step input. Okay. Now we will see the effect of the PID. So here if we enter the PID in the library search box, we will find out the different PID blocks. So simple, if I take this yes PID block, because here we are using the transfer function, so take this and put here. Now connect the PID block in between the step input and transfer function. So delete this line, take this PID block here, then connect the PID block. Okay, now this PID block is connected. If I click on play, see what happen here. Okay, we will see this type of system. This is step input and this is the output of the system if we connect the PID. Now here I want to change the KP, Ki and KD value. So double click on this. Here proportional constant, integral constant, derivative constant. Here PID, type of the PID, in that parallel and ideal, two types. So if we take the parallel PID, now I can enter that PID constant values. So proportional value, suppose 1. Here I want to change 0.1. okay, derivative value is 0. Now apply this. Okay, now see the change. Click on the run, double click here. Okay, see, we find out the another output here. This is the effect of the, if I change the integral constant. Then if I change the derivative constant, see the what happened. Double click here, give some derivative constant, suppose 0.2, apply. Okay, then play the system, click on the scope. Very small change we find out here at this position. Okay, this type likewise we can change the system by changing the values of KP, Ki and KD. If I taken 2, okay, here also 0.2, apply. Okay, play this, see the effect on the system. Okay, we find out the another graph like this. So this is the effect of the PID on the transfer function if we connect the step input. This PID giving the output without feedback. So if we want to add the feedback, here we require the summing point. Okay, so summing point first we require to add here. So for that first I want to take this summing point from this. Okay, in the mathematical operation there is a summing point, so we can find out this summing point. So enter the summing point here. So delete this first, add the summing point, then connect the step input this side, then another side to the PID block. So here we want to add the feedback to the system. So your system is this. So output of the system we can add as a feedback to the system. But see here, plus plus, two signs are different. Plus, if I want to add here, feedback is minus to the input of the system for the correction. Okay, so this is minus, plus. Then here for the mux, connect the step input. Okay, step input. Now see the response of the system, what happened. If I click here in the scope, we can find out this type of system. There is a input, step input, and the output of the system. Okay, like this. After some time it's become the constant, or the is equal to the set point for the step input. So if I add this feedback, then we can find out this system. Now here if we change the values of the PID, suppose 2, 1, okay, then click on apply, click on OK. Now play the system, click on the scope. Again we can find out the different response. Okay, Now here in the PID, one thing is given, that is tune. If we want to find out the exact values of the system, okay, then there is a one tuning method, optimization method. Okay, we can change the values manually, then we can find out the correct answer for our system. But if we want to tune the system, the already tool is provided in the MATLAB. So click on the tune, then we can find out the optimal values of P, I and D. So click this on the tune. What? See here, PID block dialog contains unapplied changes. Click apply to apply these changes. Okay. Then tune. So if we click on the tune, it's try to find out the optimal values of the proportional, integral and derivative constants. Okay, see here we can find out the two graphs, this block response and tuned response. Okay, so tuned response give the this overshoot, undershoot, and after some time it become the stable. Okay, so apply these changes or apply these values to the system. Apply these values and click on OK. See, proportional value 1.9 something, then integral 2.21, then derivative value minus 0.006. These are the optimal values for this system. Click on OK. See the output of this PID. So click on play, then click on the scope. See, after some time it's become exactly equal to the input, step input. So there is a small overshoot, undershoot. It requires some time to settle that system. So that is the settling time. All the terms we understand in the unit number 6.